Hello everyone, my name is Viraj and today we'll be looking at the 9th problem from the CP-31 sheet by TLE Eliminators under the 800 rated questions. Let's go. So I'll be moving on to my CP-31 sheet over here. I have the 800 rated parameter ticked off and I'll move on to my 9th problem, goals of victory. Alright, let's see the problem. There are n teams in a football tournament. Each pair of team match up once. After every match, Park Chanek receives 2 integers as a result of the match, the number of goals the two teams scored during that match. Now the efficiency of a team is equal to the total number of goals the team scores in each of its matches minus the total number of goals scored by opponent in each of its matches. Alright, so after the tournament ends, Park then counts the efficiency of every team and turns out that he has forgot the efficiency of one team, given that you have the efficiency of n minus 1 teams, that is a1 to an minus 1. What is the efficiency of that missing team? It can be shown that the efficiency of the missing team can be uniquely determined. Alright, so let's try to generalize this problem and understand what are they telling us over here. Okay, so I'll take up new page over here. They have of course given you an integer n, alright, but they have given you n minus 1 integers, that is the array A. So I'll call this a1, a2, then this is a3, you have a4 dot till you have an minus 1. This is something that given to us. Now of course these are integers and there is some meaning behind that integer. So they have created a whole story where the crux of the story is basically there is some tournament going on and you have some teams that are playing. Okay, so I'll name them. Let's say I have some team 1, I have team 2, I have team 3, I have team 4. 4 teams, that's all. Alright, now what are they saying is, let's say for example, each and every team is going to play with each and every team. So if let's say I talk about team number 1, then team number 1 is going to play with team number 2, team number 1 plays with team number 3, team number plays with team number 4. Similarly, team 2 plays with, of course it has plays with team 1 already, so you can say team 2 plays with team 3 and team 2 plays with team 4, and then finally can be team 3 plays with team 4. So basically every 2 pair of teams play each other. That's what they are doing. Now once they are doing this part, of course there are going to be some goals because this is sort of a football tournament that they are talking about. Alright, so let's just take an example. Let's say I take team 1 and team 3. So these 2 teams play, their players plays basically, and of course there is going to be some score, some number of goals these 2 teams do, correct? So let's say team 1 has done some score and team 3 has done some score. So let's say I'll just call this, let's say team 1 did 5 scores and let's say team 3 did 2 scores. So I'm not bothered with who wins or anything like that. That's not the case. Just imagine that this is one of the matches I have taken into consideration, that was between team 1 and team 3, and then I know they individually score something. So team 1 can be said that okay, it's scoring basically 5 goals and then team 3 scored 2 goals. Similarly, there are other matches. Of course, there will be many more matches, right? However permutation you can make for these 4 teams. And then of course every team will have their individual score at the number of goals they have stored. Now what are they saying is, they are saying that okay, if I have the team 1, then team 1 when plays with each and every team, so team 1 is going to play with team number 2, it plays with team 3 and it plays with team 4. So these 4 matches that team 1 has, let's say that the score that team 1 scores in the matches is this S1, this is S2 and S3. And let's say counter to this, the score that each and every opponent team scores is, let's say S1 dash, S2 dash and let's say S3 dash. So I'll name this again. What are they saying is scored by team 1, this is team 1. Then you can call this score by 2 team, you can call this as score by 3 team, and you can call this as score by 4 team. Alright, so I'm just going with this very simple naming convention, right? Don't confuse this yourself. What I'm simply saying is there are 3 matches of course which team 1 plays. It plays with team 2, team 3 and team 4, and then let's say individually I have these score, that is S1, S2, S3 is the score. You can say S1, S2, S3 is the score played with individually when it played with T2, T3, T4, then what T1 scores. Alright, so this is the score by T1. S1 in the match with T2, S2 in the match with T3, S3 in the match with T4. And this is the opponent score that they have scored. Now what they're saying is, if I add this column, so this is S1 plus S2 plus S3, and if I subtract from this column, that is S1 dash plus S2 dash plus S3 dash, then this is called the efficiency, or basically the A1 value for the team 1. And this is what is given to me over here, that is A1. Now I think this should be clear. Alright, so I'll just generalize this once more. When a team, currently, let's say the ith team you're talking about, when it plays with each and every opponent team, the sum of the score it does, or the sum of the goals it does, minus sum of the goals done by all the other opponent teams is the efficiency. You will call this efficiency. This is what is given in the problem also. Efficiency of T1, of team 1. Okay, team 1. In this case, when I was talking about team 1. Now, when I would ask you, how do you get A2? The argument would be, okay, when the team T2 would have played with the team T1, T3 and T4, and they would have 3 score over here that T2 has done and 3 score over here that individually T1, T3 and T4 have done. Then you can say the sum of this score, let's call this capital S, minus the sum of this score, let's call this S dash, capital S dash, is what is value A2. And similarly, you have A3 and A4 and so on. And this is called the efficiency of all the teams. Now, this is up till here. This is all the story that is given. All right, this can be pretty big. So what you can do is you can pause the video over here and first try to realize on your own what is the actual meaning of all the story that they have created. Now, once that is clear, we'll finally land on the problem. Story is told. They have given efficiencies. Now, what are they saying? The catch is that they haven't given us n efficiencies. There are of course n teams, but they haven't told us n efficiencies. They are saying that I am giving you n minus 1 efficiencies, and there is that one team whose efficiency I don't know. So I'll call this, let's say, in this case you can say an team, right? Since a1 to an minus 1 or 1 to n minus 1 teams, I know the efficiency a1, a2, a3. You can say, for example, I don't know the value an, that would be the efficiency of the nth team. This is something that's a question mark, and I have to solve for this question mark. I have to somehow calculate that what is that an or the efficiency of that last team which I was not given. Okay, so they have said this in the problem, that what is that efficiency of the missing team, and they are guaranteeing that it can be uniquely determined. So there is no case like this of a -1 or a no case or something like you cannot determine it. No, you can determine it, and it's going to be a unique value. This is the whole idea. This is the whole idea of the problem that we want to solve. Alright, great. Now let us look at one of the sample case. Let's say I'll take up the first sample case, and they have given you a very good explanation over here. Okay, so I'll take up that example. Let's say the efficiency are 3, -4 and 5. Alright, and then there is one missing efficiency because n was given 4 to you. You can see in the problem, n is given 4 to you over here, but there are actually 3 efficiencies only, 3, -4 and 5. So I can say that this is the missing term that I'm trying to look for. This is sort of the missing term that I'm trying to look for. So I can just mark this off with red. This is the question mark that I want to find. And you can just name that, okay, this is the efficiency A1, that is efficiency of team 1. This is of team 2 and this is of team 3. Now the argument is, they have given that in the first test case, this is the first test case, their explanation is, you can have such a possible tournament. What are they saying is, let's say team 1 and team 2 fight. Let's say team 1 and team 3 fight, and let's say team 1 and team 4 fight. Okay, so fourth team's efficiency is something I want to calculate. This is basically A4. I'm not picturing right now, but what they're saying is, let's say team 1 and team 2 would have fight, team 1 and team 3 would have fought, and team 1 and team 4 would have fought. Now the scores could have been like this, 1-2, 3-0 and 3-2. So in this case, if let's say I have 1-2, this is 3-0. Okay, I'll let this over here, 3-0. And then you have, what's this term? 3-2. So if I add this section, this gives me 7. And if I add this section, this gives me 4. And if I subtract, I'll get 3. So can I say 3, isn't 3 the efficiency A1? So somehow I have created a tournament which up till now is accurately giving me the efficiency that I was given, that is A1. Good to go? Understandable. Now, let's come to team number 2. Now, team 2 fights with team 3. Team 2 of course fights with team 4, but I mean this might not be very clear. Team 2 has already fought in with team 1. So the scores I would write would actually be look something like this. When team 2 fights with team 1, this is 1-4, of course. When team 2 fights with team 4, this is 1-3. This is 1-3. But then when team 2 is fighting with team 1, over here I would say that okay, team 2 has won in this case, because what they are saying is that if let's say you are talking about the efficiency, then when I'm talking about some ith team, then all I need to see is how many goals did that score, and that will get cumulated. And then I need to subtract the number of goals that its opponent had scored. So over here, when team 1 and team 2's fought, they had a score of 1-2. That meant that 1 score was made by team 1 and 2 score were made by team 2. So over here, when I want to add, I would not write this as 1 and 2 because that's the score between 1 versus 2. Basically, I can just write it at a reverse manner, which would mean that, okay, this is the score 2-1 because I want to add the scores by team 2. So team 2 scores is 1, 1, 2. This is 4. And then I want to add this up. This is going to give 4, 3, 1. This is 8. And then I want to subtract from that. This gives me -4. And isn't this the efficiency A2? Of course, this matches. So I hope you are trying to understand the logic now, right? We are not considering the case that, okay, who won? Again, remember, if let's say over here, it might be confusing that when I wrote team 1 versus team 2, then that means team 1 won. No, that's not the case. I'm not bothered with that part. All I'm saying is when some match happens, if you're talking about some ith team, very important, if you're talking about some ith team, just add its scores in all the matches it does with other teams, subtract from it the sum of all the scores that its opponent scored, and that's the efficiency. Alright, so now once this idea is clear, I'll take this on the next page. Team 3 can be written something like this, that when team 3 with team 4 fights, this is 5-0. Now team 3 with team 2 would have fought in, this is 1-4, but I will write this as 4-1 because I'm talking about team 3 first. And then when team 3 and team 1 fought, this is 3-0, but I would write this as 0-3 because this is the perspective of team 3 now. When I add the left hand side of the column, okay, I'll change the page over here, 5-0, 4-1, 0-3. When I add this up, this becomes 9 and this basically becomes 4. And when I minus this out, this becomes basically 5. And can I see that over here, 5 was the efficiency A3. Good to go. And now when I can see 3 efficiencies have matched, it would be very easy for me to calculate this missing efficiency. If you pick your pen and paper, you will get the answer directly, but you can just quickly have a glance over here also. They have given you also over here, team 4 will be 2 plus 3 plus 0. That is 2 scored by team 4. Where did it score it? Over here when it had a team 1 match. Then 3 is when it scored with team 2 and 0 is when it scored with team 3. So 2 plus 3 plus 0 minus opponents was 3 plus 1 plus 5. This is -4. So what will I say is that the efficiency of the last team, that was AN, was -4. Hence answer over here turns out to be -4. Alright, so this might be, again, I'll repeat, this might get a bit confusing. I would highly recommend that you pause the video over here and go through the test case. Once again, they have given you a very, very good explanation over here so that you get the idea. All I'm doing at the end is every match's individual score. When I'm talking about a ith team, I add all the scores, ith team scores, and I subtract from that all the scores that its opponent had scored respectively in each match, and that is the efficiency of that team. Highly recommended to pause the video and understand this so that we can move ahead in the problem, else it might be a confusion. Okay, good to go. Now that we have understood the problem, now let us move to a very, very important idea. That is, even before I start, how do I figure out what is the time complexity I am expected to solve the problem in? Alright, very important. So this is some discussion. We know that by fact, I have 1 second as 10 power 8 operations given to me. By fact, I know that in 1 second, I can perform 10 power 8 operations. So if let's say over here, it is written that time limit per test is 1 second. What does that mean? It means that in one test, basically, you are allowed 1 second, which means you are allowed 10 power 8 operations. But remember, in a test, there are some test cases. If you read this line over here, each test contains multiple test cases. So that means if I ask you what is the number of operations you can do for each test case, then this kind of changes. This becomes 10 power 8 upon, then you have each test as 500 test cases, maximum limit. So you can write this 500. And if I calculate this, this becomes basically 1 by 5 into 10 power 6 or 0.2 into 10 power 6, or to be very accurate, 2 into 10 power 5 elementary operations. Which means that every test case allows me 2 into 10 power 5 operations to perform. And this is what is helping me formulate my idea, or this ignites that idea inside my head. Because now if I look over here at n is given in 100 order. Okay, n is given approximately in, is that 100? Yeah, it's 100 order. So now, if let's say I ask you, can you create an n cube solution? That's very drastically huge, but can you do that? The question would be no. The answer, sorry, would be no. Why? Because 10 power 6 is something I would achieve if n is 100 in n cube order, and 10 power 6 is definitely above 2 into 10 power 5. So that means if I'm thinking while solving this problem, any such solution which I know or I can imagine to go in n cube, I will stop. I will never code it up. That saves me a lot of time. And this helps me go even further and ask, okay, will n square work? Of course, this works. Will O of n work? Of course. And so on till anything that constant works. So I know this doesn't work. It's sort of sort of an upper bound you can say, but anything might be below than this starts working. So this is very important because this gives me an expected time complexity solution. Now I know that I don't want to exceed some sort of an n square order. Not that I would ideally want that to happen, that I create a solution that's drastically in n square order, but then I know even if I would have to write an n square order, it will work. It's going to still make me receive an AC, not get me a TLE. Alright, this is where we can end our expected time complexity discussion. Now I have removed all the redundant ideas from our code and I can start thinking the solution to this problem. Alright, so the solution to the problem is pretty simple, by the way. Alright, the argument that stands over here is very simple. I'll write down the argument and then we'll try to understand why is that happening. Argument is the answer is simply negative of sum of all the n minus 1 efficiencies. This is the argument. I mean, this is again a very simple thing to calculate, right? If let's say I told you that the answer is this, how easy would be the problem? But the argument is, yes, this is actually the correct answer, and we'll try to understand why. Why is this happening? So for that, what I'll do is I'll go back to my explanation over here, where we took some example of the, you can say the teams, all right? Or rather, I'll insert a new page over here. Let's try to understand very simply. Let's say I took those 4 teams, that is team 1 over here, and then team 1 fought with team 2, team 3, team 4. Understand this very simply, all right? Let's not think about reporting the score directly. Let's just think that there is some match going on, all right? So there was the football match going on between team 1 and team 2. Now imagine, not in terms of score, but rather in terms of efficiency. So let's say I'll take this from a very sketch point of view, all right? I'll say right now that I had the efficiency A1 and I had the efficiency A2. T1 and T2's match happened, they were playing. Let's imagine. Now when they are playing, it can be 2 cases, right? Either you can say that team 1 scores or let's say team 2 scores. I'll take a simple example. Let's say T1 puts a score. Now the current match I'm talking about with perspective is of the perspective of T1. So if T1 scores, I know that in this time, the value of A1 has to go up by 1. Why? Why do I say this? Because effectively, I know when I'm talking about some ith team and that ith team scores, then the efficiency has to increase, because remember, net, when I was talking about T1 with T2, T3 and T4, you can see over here, I knew that, okay, I had, if let's say I had the score S1, S2, S3, that was the score done by T1, then that was getting added, not subtracted, that was getting added. So individually, if let's say T1 did put a score or did put a goal, in this case, against T2, then A1 has to increase and become A1 plus 1. I hope this is clear. But one more thing happens. Let's say that T1 has put a score. Then what would happen essentially? Remember, when we came to our case, when we discussed, okay, I'll take this on the next page. When you would consider the case talking about the whole reference from T2's point of view. When T2 was fighting with T1, T3, and T4. Now the point of view has changed and now you're talking about the team T2. The score that was done by T1 in the match between T1 and T2 is going to affect the efficiency of T2 also simultaneously. But remember, when talked about T2's point of view, T1 is an opponent. So the score that T1 did in the match between T1 and T2 did increase the efficiency of T1 as a team, that was A1 got A1 plus 1. But when it comes to the perspective of A2, that what happened to the efficiency of the team 2, you can say that that efficiency decreased by 1. Why? Because essentially if T1 had scored one goal in the match between T1 and T2, when you would have calculated with respect to T2, T1 would have been the opponent and it would have pulled down the efficiency by 1 because opponent's efficiency in respect to T2 had to be subtracted. This is a very, very, very important point. So I'll write this down. If you can say ith team scores, you can say scores against, or not ith team, let's say I'll say like this: if a X team scores against Y team, then X's efficiency becomes plus plus, but Y's efficiency goes down by 1 and it becomes minus minus. Alright, so this is very, very important point. Now let's go back. Let's understand over here that if I just took one example, that I took the match between T1 and T2, and in that also I took one single example when I said T1 scored. Now if let's say I did the opposite thing, I said alright, T2 has scored, then what would have happened? Of course I would have said that A2's efficiency goes by 1. Add 1, because now if T2 has scored, then its efficiency has to increase, because when it comes to his, or not his, T2's perspective, their efficiency will increase because the score was made by T2. But in simultaneous order, the efficiency of T1 will decrease because now the score done in T1's perspective is opponent's score. So overall the sentence is, if X versus Y happens and X team scores against Y and you're talking about X's perspective, then X's efficiency will increase, but simultaneously Y's efficiencies will decrease. Alright, so this is a very, very important point. Now why is this helping me? There is something to think about this, right? How is this helping me? This is helping me with a very, very strong observation. Okay, if let's say I maintain a variable called sum, and this sum is called A1 plus A2 plus A3 plus A4. Remember, I don't know A4 for now. That is the efficiency of team 4. That is something I did not know, but let's say it's some variable I'm solving for. Okay, so this is A4. Now, how does this sum get affected when we come to the same analogy? If let's say some team X scores, then the efficiency of X's team gets added by 1. But simultaneously, Y's team gets subtracted by 1. So if I talk about this sum variable over here, if let's say some score happens anywhere in any match between any team, what will happen? Can I say that, let's say some random two teams were fighting and one score happened by, let's say, some team X, then some efficiency in this, let's say for example, let's say in this case we took A2, A1 only, A1 will go by up by 1, but simultaneously will not some other team's efficiency go down by 1? Of course it will. So can you observe a very acute point over here, that the net sum or this variable's value, let's say this value was V, will not change, because if let's say somebody scores, this value V would have gone to V plus 1, but now again somebody did not score, or its efficiency did not, you can say did not score, its other opponent's efficiency decreased. So if it went to V plus 1, it came back down to V minus 1, which was actually, like if it went to V plus 1, then it did minus 1 again, which came it back down to V. So this sum value is a constant. This is a very, very important point. This is a constant. And since this is a constant, can I not solve for this? Of course I can solve for this. And to be very specific, do you understand what constant? Do we get this value? I do have A1 with me. I have A2 with me. I have A3 with me. I don't have A4. If let's say I know the sum value, then I will get A4 by simply saying, okay, A4 becomes sum minus A1 minus A2 minus A3. The argument is, do you know the value of sum? I know A1, I know A2, I know A3. Of course, right? By common sense. Imagine that initially you were standing at some pace and then you increased it, then decreased it, increased it, then decreased it, increased it, then decreased it. So will it ever go greater than 0 or will it ever go less than 0? Never. It will remain at 0. That is, if the sum obviously by common sense started with 0, that was initially the sum of all the efficiencies, then the effective sum of the efficiencies never changed from 0, it always remains 0. So this value is actually 0. That means I can write A4 to be solved as negative of A1 plus A2 plus A3. And isn't this something that we argued in the very start? That the argument builds something like this over here. Where did I write this? I think over here. So yeah, somewhere over here. Yeah, this. That the answer is simply negative of sum of all the n minus efficiency. This is what we proved, that A4 turns out to be negative of A1 plus A2 plus A3. Alright, now for the beginners, I can definitely argue this might be a very, very confusing problem. Alright, so what you can do is, again highly recommended, pause the video and just briefly think on this idea. Alright, go again with the teams. Alright, draw on a pen and paper, team 1, team 2, team 3, draw their matches and see what is essentially happening. And then try to imagine this sum that I talked about. That was actually the sum of A1, A2, A3 and A4. You will observe very cleverly that if this sum, of course, since it started with 0, it always remains at 0 because of the idea that we discussed over here, that if some X team is playing some Y team, the efficiency of X although increases, but efficiency of Y decreases, and since it's together in a sum, the sum value does not change. Maybe the efficiencies change. Of course, A1 will change. Of course, whoever it played with A2, let's say, or A3, it might change, go up, go down. I'm not bothered with that. But the sum value effectively will never change. It will remain stagnant, and that stagnant value is actually 0, which helps me solve for the variable A4 in this case, which effectively solves for me a very generalized variable that if let's say you start with 0, 0 becomes equal to let's say A1 plus so on till A of n minus 1, and then this plus an, which is actually a variable for me question mark, then I can just solve for this. An becomes negative of sum of all these values, which is effectively this idea. Just take the sum of all the n minus 1 efficiencies, put a negative symbol in front of it, and you're good to go. You will get the efficiency of the nth team that was not given to you. Alright, so this is one of the very unique problems where all we had to think about idea, because once you get this, the code is very, very simple. Alright, so let's move on to our coding part. Very, very simple. I'll just take the variable n with me. I'll take the array input with me. I have of course taken t over here for the test cases. And up till here, all I'm doing is taking inputs. Now, very simple. Just take a sum variable, run a loop. Now, one thing I think you can commit by mistake, that over here, see, I'm not running a loop from 0 to n or less than, sorry, I'm running n minus 1. Although I've taken the variable n input, because in the problem it was said that if n is given, the array size is not n, it's n minus 1. So that's why I'm going from 0 to less than n minus 1. That's the index n minus 2. That is something I run over here also, and something I run over here also, just so that I understand the problem. So something for you to note also. Now I simply calculate the sum of the array and I print negative 1 into sum, and this is effectively the effectively the efficiency of that last nth team, which did not had by the very constant idea that the effective sum was always 0. Right? So very, very fun problem. Let us try to understand the time complexity now. This runs in n order, of course, and this runs in n order also. Nothing very big. That means time complexity simply becomes O of n order. And since n was given 100, this is basically O of 100, and which is very, very fast. We wanted something that upper bound goes in n square, but I achieve something in O of n. So good to go. Definitely gets me an AC. And what about space complexity? Of course, depending on the size of the array. So not exactly n elements. I have n minus 1 elements, but that's order of n. So I can call this O of 100 also. I'll be good to go. Alright, so this is the whole idea behind the problem. Pause the video, draw the test cases, and you will get the problem very clearly. It might be confusing at the very start. What is happening? What's this tournament? Definitely a big problem to read and write. But then again, this creates a practice, and high rated problems, of course, have more and more intricate story for you to understand. So if you understand this problem or you practice this problem, this is going to help you create more efficient ideas later on. Alright, so I hope you like the video. Thank you for watching.